Hi, and welcome back. In this discussion, we're going to talk about properties and action methods and controls. When we talk about properties in this discussion, specifically, we're talking about outlet properties that refer to passive controls upon our view in the view controller. Now, these properties and these methods, even though they function with the controller's view, they're declared in the view in the controller itself. So we're going to talk about how things happen there and some important attributes of these properties as we go along. So as I said, we're talking about outlet properties of the view controller. In a view controller, any control whose properties we need to change, like the text of a label or the text on a button or maybe the background color of the view itself, any control that we want to change the look and feel of at all in our code should be declared as a property, non-atomic, and weak. Non-atomic in this context means that we're running on the main thread. We're not worried about thread blocking at all here. So don't put any semantics in the setter to control atomicity. In other words, make it thread safe. Non-atomic means don't worry about all that thread safe code in the setter. Weak, we're going to talk about here in the next slide, but weak just basically means that they're going to be owned by something else. They're not owned by the controller. They're going to be owned by the view that the controller is controlling. We also use this keyword IB outlet, and then the type of the control, and then the name as a pointer, because as we know, objects are all pointer types. So the name, we give it. So outlet properties are declared weak since they're owned by the controller's view, and again, we're going to talk about that here in the next slide. IB outlet is simply a flag to Interface Builder, and we can see that it is a define IB outlet as nothing. It's just a flag so that that define exists, that symbol exists, so that the compiler picks it up and says, this in Interface Builder is wired to some control. And that's how that works. It also allows Interface Builder to inspect the code and check and see if it has a control that can be wired to that type of property. And then it allows that wiring to happen. Type is the class of the control, like a UI label or a UI segmented control or even a UI view that's a subview of the main view. So type is the class of the control, the class name of the control. And name is the name of the property that refers to the control. And this name is given to that property by the developer. So now let's talk about strong and weak properties. Strong and weak properties exist. iOS doesn't have garbage collecting. It is not a garbage collected environment. Objective-C is not garbage collected. Instead, it uses something called reference counting. It operates in a reference counting environment. Now, since iOS 5, we have a new wrapper around our programs called automatic reference counting. We can still reference count, but we have to set a flag in the compiler to compile the code without automatic reference counting. Automatic reference counting is not garbage collection. It still relies on the reference count. So what is a reference count? A reference count is simply a count of the number of references made to an object. In other words, how many classes, how many objects have a pointer to this object? And how many pointers does maybe one object have? In other words, the sum total of the number of references to every object is that object's reference count. When that reference count reaches 0, the object is going to be released. But it doesn't get released immediately. It gets released at the end of the current iteration of the run loop. Now remember that we said that UI application main really fires off that run loop. You may have noticed, and if not, we'll, in the demonstrations throughout the rest of the course, we'll see the main function wrapping up this call to UI application main. And in our demo code please look at the main function. It's in the supporting files folder. Please look at that main function, and you'll see that the call to UI application main is wrapped up in an @auto_release_pool construct. That auto_release_pool tells the run loop to release anything with a reference count of 0 at the end of its current iteration. So that's how that reference counting thing works. Now, what about strong and weak? Well, if we declare a property to be strong, it's born with a reference count of 1. Now, this may seem like what we'd want to do all the time, but not really. If a property is not an outlet, though, it needs to belong to the view controller or whatever class that it created, that created it. And it should therefore be marked strong. It should have a reference count of 1 because we don't want it to be deleted at the iteration at the end of the current run loop. But if a property is going to belong to something else, like an IB outlet property, which becomes the property, so to speak, of the view of that view controller, then we need to declare it weak, because weak properties are born, so to speak, with a reference count of 0. We don't want the view controller itself to have a reference count to that property. We want it, when it assigns that control to the view, we want the view to have a reference to that property. And the way we do that is we declare that property to be weak. Therefore, having a born with a reference count of 0, when it gets assigned to the view, it will have a reference count of 1. And then when the view gets deleted, there will no longer be a reference to it, and we don't have to worry about deleting the control itself. So just again, let's look at this again, because it's a very simple idea, but it can be kind of complicated to understand at first. On the left, we have a view controller, which declares 2 properties. The first one is just an NSObject property. Don't worry about what it is. It doesn't matter. We have declared it as strong. And we can see that this NSObject exists within that view controller. And because we've declared it to be strong, it has a reference count of 1. We've also declared a weak IB outlet UI label property. Now, for a split second until that view comes online, that UI label exists here with a reference count of 0. But sometime later in the current run loop, the view is created, and that the view grabs this object, this UI label, and as soon as that happens, as soon as the view takes ownership, it has a reference to this object, and therefore that object now has a reference count of 1. And this is exactly what we want. So this weak IB outlet is how we need to declare our outlet properties that will be on views as subviews of the main view in our view controller. So now when the view is created, it itself is a strong property of the controller. Now we don't see this because the view itself in Interface Builder is just a big XML file. That XML file is compiled into a UI view object that becomes a property of the view controller. That happens behind the scenes. We don't see that happening. But it's created. That view itself is a strong property of the controller. When that strong property, when that view is deleted, if all of its controls were made weak by the view controller, when the view is deleted, all the controls will then have a reference count of 0 because there's no reference to them because its view, their view, has been deleted, and they will be deleted as well. So this is the difference between a strong and weak property. So now the other side of the coin is action methods. Methods that respond to user events on a view should be declared in this way. So we see that these are class methods. We see that these are instance methods, the dash rather than the plus at the beginning. And then we have this strange return type, IB action. We'll talk about that in just a moment. And then of course we have the method name, and then we have one parameter that is a type of the control as a pointer. And then usually this word is sender. It can be anything. It is the name of the parameter. But by convention, we use the word sender. It just makes things easier because sender means the thing that sent the message. IB action is like IB outlet. It's just syntactic sugar. It's an indicator to interface builder, and of course it's type def void IB action. So really, when you declare this method, you're declaring a return type of void. It doesn't return anything. But IB action is type def to void so that interface builder knows that this method can be wired to some control of the type of the control. Control type is the actual class type of the control. This could be a UI button. It's whatever that control is that you drug out onto the screen in Interface Builder. It's the type of that control. If it's a UI segmented control, if it's a UI text field, UI text view, whatever that control's type is, use it here. It makes things a lot easier. We can also declare this to be of type ID because we know that ID means any object. But then we have to go through and make sure if we're going to do anything with the sender, we need to make sure that the sender is really a button or really a segmented control or really a text field or whatever it is. So that control type really, this parameter should really be typed to save ourselves some trouble. Sender, of course, is named thus by convention. It's the control upon which the user event occurred. The button press, the segmented control value changed, whatever. And, of course, since IB action is really void, nothing is returned from this action method. Okay.